When we analyze a graph, we want to basically break it apart into every little piece we can and examine it in every little detail we can find. So there's various things they may ask you in a graph. Let's go ahead and start with looking at coordinates. They may ask you questions like this: find f of 0. Well, remember, this number right here represents our input, our domain, our x value. And so what this is really asking you to find is, what's the y value when x is equal to 0? Well, if we look at our graph, when x is equal to 0, y is equal to 4. So the f of 0 value they want is just 4. Next up, they say find f of 3/2. Well, again, find 3/2 as an x value. The y value is 0. So f of 3/2 is equal to 0. And finally, they say find f of 3 pi. So again, find where x is equal to 3 pi and read the y value. If I look at my graph, there is that point on the graph. So the y value, the f of x value, is equal to -4. The next question kind of asks you the opposite of that. They give you the f of x, which remember is really just a fancy y. So they give you a y value of -4 and ask you for what values of x, y is equal to -4. So take a look at your graph and find where y is equal to -4. And it turns out there's two values x could be. X could be equal to pi, there's one coordinate. Or x could be equal to 3 pi. There's a second coordinate. Okay? The third kind of thing they can ask you about coordinates is this question. Find f of 4 pi. And they want to know, is the graph positive or negative? In other words, if you find an x value of 4 pi, is the graph positive above the axis, or is the graph negative below the axis? So let's find where x is equal to 4 pi on the graph. I can see it up here, and I see that my graph is above the x-axis at this point. So this value must be a positive value. Another way we may be asked to analyze a graph is to take a look at its domain and its range. And to describe these, let's go ahead and use interval notation. So I'm asked to find the domain of f. In other words, how far does the graph go to the left, and how far does the graph go to the right? Well, if I look, I definitely have a stopping point on this graph. There's no arrows. The graph stops right here, and the smallest x value then the graph could be is 0. Okay? The biggest x value the graph could be, if I go all the way to the end of the graph, again, it does hit a wall, it stops over here, and I'm looking at x values for my domain. So the biggest value of x I have is equal to 4 pi. So I'm not doing a coordinate, don't confuse that. I'm doing an interval notation. My graph is going to be between 0 and 4 pi. I've also got to figure out what kind of symbols I can use. I can use parentheses if I'm not allowed to equal those values, or I can use these braces, these squared off brackets, if I am allowed to be equal to those values. Well, I can check my graph and I can see that, yeah, I can get all the way to 0. There's a filled in circle, so I can use these squared off brackets to say that that's my domain. Okay? Range is your output, your y value. So what I want to do to find range is I want to look how far down does the graph go and how far up does the graph go. What's the lowest and the highest y values I can find? Well, looking at my graph, I can see the low point, the lowest my graph gets to is -4. Remember, y values this time. The highest the graph gets to, up here, is +4. So I'll do -4, 4 to indicate that my range is anywhere between those values. And once again, I can get to those locations. So I'll use these squared off brackets to say that I can be equal to 4 or -4. And then anything in between there describes my range. Some more ways we may be asked to analyze a graph is to look for intercepts, where the graph crosses the x-axis or where it crosses the y-axis. So let's start with x-intercepts. I want to know every spot where this graph crosses the x-axis. Well, I can see that there are 4 of them. So this time I'm just listing coordinates. Again, be careful that we don't mix up coordinates and interval notation. So the points where the graph crosses the x-axis are pi over 2, 0. I've got 3 pi over 2, 0. And if I list them all out, which I guess I'll do, I have 5 pi over 2, 0, and then 7 pi over 2. Now you'll notice all of my x-intercepts have a y value of 0, and it makes sense. If I am touching the x-axis, I'm not moving up or down at all for a y value. My y-intercepts then are where my graph crosses the y y-axis. And so if I look at the y-axis, I can see that there is, well, exactly 1 point where that happens. And so my y-intercepts this time are just 0, -4. Again, the x value will always be 0 for a y-intercept. Okay? I may be asked about intersections, where lines intersect graphs. They asked me about the line y equals -2, and they ask how many times does that intersect my graph. Well, the line y equals -2, hopefully you recall, is a horizontal line. So if I count down 2 spaces and draw a horizontal line, I can see that my graph touches that line a total of 4 times. They don't ask me for the coordinates of the intersection point. They may later, but for now they don't. And then by process of elimination, x equals must be a vertical line. So they asked me how many times does the vertical line x equals 0 intersect the graph. Well, it turns out that that vertical line, x equals 0, is just the y-axis. So there is 1 intersection point. In fact, you may notice that any vertical line you draw, so if they give me any x value, it's only going to touch 1 time. If you recall from Algebra 2, this is your by the way question. Since a vertical line touches the graph only 1 time, we know that it's a function. We had called that the vertical line test. So any vertical line we draw touches the graph just 1 time. That proves it's going to be a function. Okay. Last question they may ask you is about intervals. Where is your graph? This is what the question is asking. Where is your graph less than 0? In other words, where is your graph underneath the x-axis? So let's go ahead and take a look at our graph and see where it is less than 0 or underneath the x-axis. Well, I can see there's an interval between here. There's one spot where my graph is underneath the x-axis. So let's go ahead and do interval notation to describe where the graph is underneath the axis. The lowest x value where I'm underneath is that pi/2 value. Okay, be careful. Again, we're not doing a coordinate right now. We're doing an interval notation. So I want to know what the biggest x value is before I stop being below the x-axis. So that's the x value over here, 3 pi/2. Not a coordinate, an interval notation. Okay. As far as parentheses or brackets go, I'm not allowed to be equal to 0. I want to be just underneath 0. So I'm going to use parentheses to indicate that I can't quite get to those values. If I got to those values, I'd be equal to 0. I'd be on the axis, and I don't want that. I want to be just underneath it. Okay. And then as you look, there's one more spot where you're underneath. That's this interval over here. So if I describe that again, I want the lowest and the highest x value between those, or between that section. So 5 pi/2 and 7 pi/2, and then anywhere in between there are also going to be underneath. Again, because I can't be equal to 0, I just have the parentheses. If I was allowed to be equal to 0, I'd use brackets, but in this case, just parentheses.